All right, hi everyone. In this video, we are going to talk about how we can wrangle SF objects, simple features objects in R. So at this point, we've done some work. If you're just tuning in, there are links to this Posit Cloud project in the description of this video. And what we've done so far is we have loaded up a shape file into a SF object we called US underscore SF. So if you haven't done that step, you would want to play the previous video to make sure you catch up and you've got that shape file imported. And we have an SF object now in R, which is called US underscore SF. And so if you've got that loaded, then we're ready to go and talk about how we can wrangle that SF object. So an SF object is a data type. It's similar to how a tibble is a type of data frame, but it has some extra structure. We have a column, geometric object column, geometric list column. And so there are some additional structures that we have in an SF object that are not in a generic data frame. But these are data frames, so we can enter an SF object into any function that takes a data frame as an input, and it's going to behave very similarly. So that's great. That means we've already talked quite a bit about how we can wrangle data frames. We can use packages such as dplyr and tidyr and things like this to tidy up an SF object. So in some sense, these are data frames. We've talked about how we can wrangle data frames. So we can just apply all of the techniques we've learned to SF objects. So for example, this variable in the US underscore SF data frame is the abbreviations of each state. So if I run this code cell, it's going to extract that information, but it's just going to store it as a vector. So here's a vector of all of these state abbreviations. And I believe there's also Puerto Rico and DC. If you look through these, I think these are possibly organized in terms of like decreasing size. Okay, so that's pulling off this information as a vector. We can also subset. So this column STUSPS, state postal abbreviations, is the fifth column in that data frame. So if I use US underscore SF, square brackets, and I index, I leave the row index blank. That's going to pull off all rows from column 5. But the difference now is that this retains the data frame structure, and this retains the SF object structure. So as opposed to getting a vector back over here, this pulls off the state abbreviations, and it also pulls off the geometry list column. So although it looks like I only asked to see column 5, it gives me column 5, and it also gives me the geometry column. And I can do this in other ways. So we've also talked about how you can index using the column name, and that gives me a very similar output, the exact same output. I can just indicate the column name without putting a comma before it, and that does the same thing. So I don't even need to indicate which rows I want to keep. Putting the data frame name and then the name of the column in quotes, that's going to pull off that column and maintain the data frame structure, in this case, the SF object structure. And we can use pipes and commands from dplyr as well. So over here, I'm going to pipe in this SF object into the select function, and it's going to ask it to select just the column named STUSPS. And running that code gives me the same exact output as the previous commands. So what's nice is these functions are treating this data frame in some sense similar to how it worked with other data frames, but it is recognizing that this is sort of a special data frame. It has this geometry column, and it also includes that geometry column with the output. We can select rows in similar fashion. I can use indices, so this will pull off the second and third rows, but keep all of the columns. So this is a little bit harder to read since these rows are broken up. But here's row two. Here's all the information about row two, how much land area and water area there are, and it keeps that last geometry column as well, so we can actually see all of the points that were used to make up the boundary of California. And we can see all of the points that were used to create the polygon, which is Kentucky. Here are some other commands that we could use. So we can take a look at the output here. So this is going to go in and index by a logical test. So this is going to pull off all of the columns, excuse me, all of the rows that have a postal code which is equal to Colorado. So we'll play that, and that's just one row, which is Colorado. And I can see various attributes of Colorado as well as the geometry of Colorado. Here's another way that we could do it. So here is a nice logical test here. So this is using the starts with function, which is a base R function, which is going to go in and say, hey, look at any of the state abbreviations in that SF object and keep any state that has an abbreviation that begins with C. So that's what this is saying. So for any, this is a logical test. For any state abbreviation that starts with T or C, the result would be true, and it's going to keep that row. For any row that does not have a state abbreviation that begins with C, the result of that test is false, and it would not keep that row. So here we're going to keep California, Colorado, and Connecticut because those are the only three states that have an abbreviation that begins with C. And I could similarly do that same exact operation using dplyr, using a pipe into the filter command. And this is filtering the exact same way. It's going to keep all of the rows that have a state abbreviation that begins with C. So that gave us the exact same information. So the point that I want to make is that we can still extract and slice SF objects similar to how we sliced data frames. We can do indexing, we can do logical indexing, we can use dplyr. All of that still works with SF objects. And here's a particularly nice feature about SF objects that aren't necessarily true in general about data frames. And so here in this first code cell, I'm going to create a new SF object called CO. And this is going to pull off just the Colorado observation, right? So this is going to pull off all of the rows in the US underscore SF data frame SF object that have state name, which is equal to Colorado. So that would obviously just be the state of Colorado. So I'm going to run this code cell. It's going to set up a SF object with only one observation, Colorado. And we can see what the class of this is. It is an SF object, and it is a data frame. So it has this additional SF structure in it. And so here's the nice thing. So this has a geometric list column that just has the polygon that describes Colorado. Now I can index an SF object with another SF object. So that's what I'm doing here. So Colorado is a data frame. And so if I insert into US underscore SF, and here what I want to do, it looks weird, right? We're trying to pull off rows CO, and CO is an SF object. So what this is going to do is it's going to pull off all of the geometry objects in USSF that intersect Colorado. So Colorado is another SF object. So Colorado has a border. So any other state that intersects it is going to share that border. So what we're going to do is we can kind of plot this out. Um, let me do yeah, so let me kind of just do one of these. So the first thing I'm going to do is just run this command. Let me get rid of these two from this code cell. So if I run this command, this is pulling off, I could see which states are bordering Colorado. Nebraska, Colorado intersects itself. Utah, Oklahoma just barely borders Colorado. Wyoming, Kansas, New Mexico, and Arizona literally has a point intersection with Colorado. This is at the 4 points, but that does intersect Colorado because they have 1 point in common. Let me insert a code cell here. And I'm going to put this in. And let me put a second code cell in. So I want to look at the output of each of those commands separately. So I'm going to run two different code cells for these. Okay, so we can plot, so CO intersect, we can see now this is a simple feature object itself. So if I just say plot Colorado intersects, and then I indicate what variable we want to extract. And here I'm going to use a character variable name and hit play. And what we can see here is that it gave a different color to each state. Each state is a different value, so each state gets a different color. And it just chose these colors based on the palette that we picked. So here we get a nice colored map. We can see Oklahoma just barely borders Colorado over here, and Arizona has this point intersection at the 4 corners with Colorado. If I don't put the name over here, then it's only going to print the geometric list column, and it's not going to print any of these other variables that we have in our data frame. So we're going to get a different map here. We haven't included any attribute on this plot, so it doesn't color anything. It just plots the polygons that make up the geometric listing column, but it doesn't color the polygons in any sort of way because we haven't associated any attribute to each of these states. Okay, so I'll stop here, and in the next video, you'll have a chance to practice this, and then we'll move on and talk about how we can merge these data frames with other data frames. We'll do some additional wrangling after question 2. Thanks.